sometimes you're going to get trig questions which at first look quite challenging to integrate. It could be like number 2 here, where there are two different angles being multiplied together, or it could be like 3 or 4 where there's a squared going on, but that squared isn't in the regular table of derivatives. And so when you get this, you're going to need to look to the formula sheet and apply one of the many trig formulas or identities. Now, number 1 can actually be done using quite a few different methods. I'm going to show you 2 of them. One is one that we've already looked at, and that is we've got 2 things we multiply together, so perhaps there's a differentiation of one of them going on. Now, in this case, I know that sine 2x differentiates to cos 2x, but I also know that cos 2x differentiates to negative sine 2x. So there are quite a few options, but what if I just pictured that there were brackets around the sine 2x and it's to the power 1? If I were to differentiate that bracket, I get cos 2x times by 2. So that is on the other side. So I could just look at integrating that one term there. I'm going to get sine 2x in brackets to the power 2, because I've raised the power of the bracket by 1. I've still got the other term there. I'm now going to divide by the new power and by the derivative of that bracket. So that would be cos 2x times by 2. Those 2 cancel, and we get sine squared 2x over 4 plus c. So that is one option, and we could have also done it with the cos in brackets, and that would have given us a different answer, but mathematically they still would have been the same. I want to show you a second option that is now using trig identities. Sine 2x cos 2x, well, for both the sine and cos, they've got the same angle, and so we can look to the double angles section of our formula sheet, which says sine 2a equals 2 sine a cos a. Let's put this down here. Sine 2a equals 2 sine a cos a. And if I compare that to what we had before of sine 2x cos 2x, we're sort of trying to compare this to here. So, well, how do I then get my sine 2a cos 2a to not have a 2 in front? Well, I'm going to divide by 2. So we've got sine 2a divided by 2 is equal to sine a cos a. Now in my case, I've got sine 2x cos 2x, which means that a must be equal to 2x. That means that sine of 2a, well, if a is 2x, then 2a will be 4x over 2 is equal to sine 2x cos 2x. So now I can integrate. I'm integrating sine 4x over 2 instead of integrating sine 2x cos 2x. That gives me, well, sine integrates to negative cos. I get negative cos 4x over 2, and then divide by the derivative of that angle times by 4 to the bottom plus c gives us negative 1/8 cos 4x plus c. Now these are 2 very different answers. The negative 1/8 cos 4x plus c is quite different to sine squared 2x over 4 plus c. But if you were to apply a few more of our rules, you could show a way to rewrite what we had here as this one here. Now, the ability to do 2 different things is not always the case. That only applies here because the sine 2x and cos 2x have the same angle. Sometimes you get with a different angle. So number 2, 4 sine 3x sine x. We've got two different angles going on here, so we need to look in our formula sheet to find something which allows for two different angles. And that will be in our product section. We've got four different products. They all work in a similar way. And we want to look for one that has a sine A and sine B, where A and B are different angles. That is here. So I'm just going to rewrite that formula out. Two sine A sine B equals cos A minus B minus cos A plus B. And I want to get this into a form where it's 4 sine A sine B. So I'm going to multiply all this all by 2. And when I put my multiplying by 2, I'm going to put the 2 in front of both as opposed to multiplying 2 by the whole thing in brackets. Now we have 4 sine A sine B, and in the original integral we had 4 sine 3x sine x. Well, that means that A is 3x and B is x. So applying this to this, we now get integrate 2 cos of A minus B, that will be 2x, minus 2 cos of A plus B, that will be 4x. Now we're in a much easier position to integrate. So integrating, we're going to get equals, well, cos integrates to sine. So we get 2 sine 2x, then divide by the derivative of the angle, minus 2 sine 4x, divide by the derivative of the angle, plus c, gives us sine 2x, minus a half sine 4x, plus c. So any time that you have a sine times by a cos, or a sine by a sine, or a cos by a cos, you can apply any of these products to calculate that. Now, it's worth saying that it's easiest if A is greater than B. It doesn't have to be, but if A is smaller than B, you end up with a negative angle, which is fine, but can cause silly errors later on. And so, if you ever have the case where instead of like this one, it was written as 4 sine x sine 3x, well, since these are all being multiplied together, you can just swap the order to bring it back to 4 sine 3x sine x. The other time that you're going to use trig identities is when you have squareds, particularly cos squared or sine squared. Now, we haven't covered how to integrate cos squared yet, and that's because when it's written as cos x all in brackets to the power 2, it's not being multiplied by a derivative of that bracket, and so there's no way that you could have ended up differentiating to be left with just cos squared x. So instead we're going to be using a formula, and the formula we're going to be using for any cos squared or sine squared is one of these formula here, particularly the bottom two, where cos 2a is equal to all of these things. Because I want just a cos squared, I'm going to use this one here. But if you wanted to integrate a sine squared, you would use the one below. So I'm going to rewrite that formula out. Cos 2a equals 2 cos squared a minus 1. And I'm going to rewrite this for cos squared a. So add the 1 plus cos 2a equals 2 cos squared a. Divide the 2, we get 1/2 plus cos 2a over 2 equals cos squared a. Comparing this to the original question, we wanted to integrate cos squared x, which means that a is equal to x. And so now I'm going to be integrating 1/2 plus cos 2x over 2. Right, to integrate that, 1/2 goes to 1/2x, cos goes to sine, so that would be sine 2x over 2, and then I've got to divide by the derivative of the angle, which is like timesing by 2, plus c, to give us a final answer of half x plus 1/4 sine 2x plus c. A final question is integrating tan squared x. Well, tan squared x does not have a derivative partner, but if we look at our identities, we can see that tan squared is paired with sec squared. Sec squared does have an integration. Sec squared integrates to tan. Now this will be the same if you have cot squared. Cot squared doesn't have a direct integral, but cosec squared does. So I'm going to use that identity, tan squared theta plus 1, to rewrite our question. So firstly, I know that tan squared theta plus 1 is equal to sec squared theta, which means that tan squared theta is equal to sec squared theta minus 1, which means I'm going to integrate. Instead of tan squared 2x, I can use sec squared 2x minus 1 minus 4 over x dx. So integrating that, sec squared goes to tan, so that would be tan 2x divided by the derivative of the angle, 2. 1 will just go to x, and 4 over x, well that integrates to 4 ln x. And then finally plus c. So I have not covered the use of every single rule here, but hopefully enough to get you started. If you ever get some sort of product or hard integration that involves trig and you're not sure what to do, look to your formula sheet and try and find a pair that gives it something that you are familiar with integrating.